A guide at the Natural History Museum in London stated confidently that a particular dinosaur fossil was 70,008 years old. When asked how he could be so precise, he said, "Well, it was 70 million when I first got this job, and that was 8 years ago." I must add a similar margin to the estimate of 100 years that Valentina Cruz, my Galapagos guide, gave me for the age of the black lava fields on the island of Santiago. The exact age of the Great Santiago eruption is not recorded, but it definitely happened on one particular day in one particular year around the turn of the 19th century. I shall call it SV Day, Santiago Volcano Day. I need to seem as precise as the museum guide, although the exact date doesn't matter. Perhaps it was January the 19th, 1897, 100 plus 8 years before my visit to the island. SV Day was one day in the late 19th century, a day on which, elsewhere in the world, somebody's grandfather was born at some particular hour, somebody else died, a moustached young man in a straw boater met his true love for the first time and was never the same again. Like every day that has ever been, it was a unique day, every second of it. It was also the date of the great Santiago volcano, the one that made the lava fields that I walked, in the company of lava lizards, Tropidurus albemarlensis, although I knew it only when they moved and betrayed their camouflage. Lava lizards are pretty much the only things that do move over these barren fields of black, clinker-ringing rock, and as they do so, their splayed hands are feeling, though they do not know it, the fingerprints of past time. Fingerprints? Past time? Wait, that is the theme of the lava lizard's tale. Santiago was one of the 4 Galapagos Islands on which Charles Darwin landed in 1835, and it was the only one where he spent any time, camping for a week while Captain Fitzroy took the Beagle to fetch fresh supplies. Darwin called it James, for he and his shipmates used the English names of all the islands, the evocative Chatham, Hood, Albemarle, Indefatigable, Barrington, Charles, and James. He and his small camping party had trouble finding a clear spot to pitch their tent, so thickly did the land iguanas carpet the ground. Today, there are no land iguanas left on Santiago. Feral dogs, pigs, and rats did for them, although there are still plenty of land iguanas on other islands of this iconic archipelago, while the closely related marine iguanas abound on all the major islands, including Santiago. The black lava fields of Santiago are an unforgettable, almost indescribable spectacle. Black as a female marine iguana, of course the simile really should go the other way, the rock is called rope lava, and you can soon see why. It is drawn out and plaited in twisted ropes and pleats, folded and gathered like a black silk dress, coiled and whirled in giant fingerprints. Fingerprints, yes, and that brings me to the point of the lava lizard's tale. As the lizard scuttles over the black lava of Santiago, it is treading the fingerprints of history, rolled out by the sequence of particular events that transpired minute by minute on one particular day late in Darwin's century, marking the minutes of that day, the day of the Santiago volcano. There cannot be many other ways to see laid out before you a complete history, second by second, of one particular day more than a century ago. Fossils do the same thing, but over a much longer time scale. The molecules of a fossil are not the original molecules of the animal that died. Even fossil tracks, like those Mary Leakey found at Laetoli, don't really do it. It is true that Laetoli shows you the exact places where 2 individual Australopithecus afarensis, those diminutive hominids carrying chimpanzee brains around on human legs, perhaps a mated couple, placed their feet during a particular walk together. There is a sense in which these footprints are frozen history, but the rock that you see today is not as it was then. That couple walked in fresh volcanic ash, which later, over thousands of years, solidified and compacted to make rock. The lava ropes and pleats of Santiago, those giants' fingerprints, are still composed of the very same molecules that were frozen into precisely those positions only a century ago. And the timescale over which the distinct ropes and pleats were laid down is a timescale of seconds. Tree rings do it on a timescale of years. Where the worlds of lava fingerprinting are laid down second by second and fossils are laid down by the millions of years, each tree ring marks exactly 1 year. Thick rings or thin label good growth years or poor, and because every sequence of half a dozen years or so has its own characteristic pattern of good and poor years, the patterns can be recognized again and again in different trees as labels of particular clusters of years. Old trees and young trees show the same fingerprints, so, by counting rings and daisy-chaining the patterns from increasingly ancient wooden relics, archaeologists can compile a catalogue of fingerprints outspanning the longest living tree. Something similar can be done with sediment patterns laid down on the sea bottom and revealed in cores of mud taken up in deep sampling tubes. And over the longer time span of hundreds of millions of years, the named strata of the geological series are, in their own way, fingerprints of time. What is so remarkable about the lava fields of Santiago is that these fingerprints were set out on the timescale that we humans deal with every second of our lives, the timescale of musical notes, the timescale of an artist's brush, the timescale of everyday actions, and the stream of human thought. This is a real thought for a surreal landscape. And the Galapagos Islands are replete with images that could have come straight from a surrealist's canvas. A tiny desert island off Santa Fe, Barrington to Darwin, looks fit for Man Friday, except that instead of palm trees, there are giant cactuses, as if the Arizona desert had been transplanted into an azure sea. No surrealist could have done it better. And what are sea lions doing in the Arizona desert, to say nothing of shocking pink flamingos, equatorial penguins, or flightless cormorants earnestly hanging their impotent stubby wings out to dry? As for the large flounder that I saw when snorkeling off North Seymour Island, it was pure Salvador Dali. Changing colour to match the corals over which it slid like an oval carpet, I would certainly not have spotted it if Valentina had not gracefully dived to point it out to me. It was only later that my wife compared the flounder to the flowing, bending watch of a Dali painting. And wasn't that very painting, the one with the bent watches, called The Persistence of Memory? Not a bad title for the lava fields of Santiago, scuttling ground of the Galapagos lava lizards. Reality, if you go to the right place and see it in the right way, can be stranger than any surrealist's imagination. No wonder Darwin drew his inspiration from these enchanted islands. The Giant Tortoise's Tale, Islands Within Islands. I am writing this on a boat in the Galapagos archipelago, whose most famous inhabitants are the eponymous giant tortoises, and whose most famous visitor is that giant of the mind, Charles Darwin. In his account of the voyage of HMS Beagle, written long before the central idea of the origin of species focused itself in his brain, Darwin wrote of the Galapagos Islands, "Most of the organic productions are aboriginal creations found nowhere else. There is even a difference between the inhabitants of the different islands, yet all show a marked relationship with those of South America, though separated from that continent by an open space of ocean between 500 and 600 miles in width. The archipelago is a little world within itself. Considering the small size of the islands, we feel the more astonished at the number of their aboriginal beings and at their confined range. We seem to be brought somewhat near to that great fact, that mystery of mysteries, the first appearance of new beings on this earth." True to his pre-Darwinian education, the young Darwin was using aboriginal creation for what we would now call endemic species, evolved on the islands and found nowhere else. Nevertheless, Darwin already had more than a faint inkling of that great truth with which, in his mighty maturity, he was to enlighten the world. Writing of the small birds now known as Darwin's finches, he said, "Seeing this gradation and diversity of structure in one small, intimately related group of birds, one might really fancy that from an original paucity of birds in this archipelago, one species had been taken and modified for different ends." He could as well have said the same of the giant tortoises, for he himself was told by the Vice-Governor, Mr. Lawson, that The tortoises differed from the different islands, and that he himself could with certainty tell from which island any one was brought. I did not for some time pay sufficient attention to this statement, and I had already partially mingled together the collections from 2 of the islands. I never dreamed that islands about 50 or 60 miles apart, and most of them in sight of each other, formed of precisely the same rocks, placed under a quite similar climate, rising to a nearly equal height, would have been differently tenanted. And he said the same thing about the iguanas, both marine and land, and the plants. With the benefit of hindsight, Darwinian hindsight, we post-Darwinians can piece together what happened. In every one of these cases, and this is typical of the origin of species everywhere, it is islands that constitute the vital, though accidental, ingredient. Without the isolation provided by islands, sexual intermingling of gene pools nips species divergence in the bud. Any aspiring new species would be continually flooded by genes from the old species. Islands are natural workshops of evolution. A barrier to sexual intermingling is what you need to allow that initial divergence of gene pools which constitutes the origin of species, Darwin's mystery of mysteries. But islands don't have to be land surrounded by water. To a highland-breeding giant tortoise, each of the 5 volcanoes along the length of the big island of Isabella, Albemarle to Darwin, who used the traditional English names, is an island of green habitability surrounded by inhospitable lava desert. Most of the Galapagos Islands are a single volcano, so the 2 kinds of island coincide. But the big island, Isabella, is a necklace of 5 volcanoes, spaced from each other at approximately the same distance as the single volcano on the neighbouring island of Fernandina, which, from one point of view, might as well be a 6th volcano on Isabella. To a tortoise, Isabella is an archipelago within an archipelago. Both levels of isolation have played a role in the evolution of the giant tortoises. All the Galapagos giant tortoises are related to a particular mainland species of land tortoise, which still survives and is smaller than any of them. At some point during the few million years that the islands have existed, one or a few of these mainland tortoises inadvertently fell in the sea and floated across. How could it have survived the long and doubtless arduous crossing? Well, the early whalers took thousands of giant tortoises from the Galapagos Islands to their ships for food. To keep the meat fresh, the tortoises were not killed until needed. But they were not fed or watered while waiting to be butchered. They were simply turned on their backs so they couldn't walk away. I tell the story not in order to horrify, although I have to say that it horrifies me, but to make a point. Tortoises can survive for weeks without food or water, easily long enough to float in the Humboldt Current from South America to the Galapagos Islands. And tortoises do float. Having reached the archipelago, the tortoises did what many animals do when they arrive on an island. They evolved to become larger, the long-noticed phenomenon of island gigantism. If the tortoise story had followed the finch pattern, they would have evolved a different species on each of the islands. Then, if there were subsequent accidental driftings from island to island, they would have been unable to interbreed, that's the definition of a separate species, and would have been free to evolve a different way of life from their colleagues of different species on the new island, and also from their colleagues of the same species on other islands. You could say that the different species' incompatible mating habits and preferences now constitute a kind of genetic substitute for the geographic isolation of separate islands. Though they overlap geographically, they are isolated on separate islands of mating exclusivity, so they can diverge yet further. Most of the Galapagos Islands have the large, the medium, and the small ground finch, which specialize in different diets. These 3 species surely originally diverged on different islands and have now come together where they coexist as different species on the same islands, never interbreeding and each specializing in a different kind of seed diet. The tortoises did something similar, evolving distinctive shell shapes on the different islands. The races of tortoises on the larger islands tend to have high domes. Those on smaller islands have saddle-shaped shells with a high-lipped aperture for the head at the front. The reason for this seems to be that the large islands tend to have enough water to grow grass, and the tortoises there are grazers. On the smaller islands there is often not enough water to grow grass, and the tortoises have to become browsers on cactuses. The high-lipped saddle shell allows the neck to reach up to the cactuses. The cactuses, for their part, grow higher and higher in an evolutionary arms race against the browsing tortoises. The tortoise story adds to the Finch model the further complication we've already noted. For them, volcanoes are islands within islands. They provide high, cool, damp, green oases surrounded by dry lava fields at low altitude which, for a giant tortoise, constitute hostile desert. Most of the islands have but a single volcano, and each has its own single species or subspecies of giant tortoise. Some have none at all. The big island of Isabella has 5 major volcanoes, and each of them has its own species or subspecies of tortoise. Truly, Isabella is an archipelago within an archipelago. And the principle of islands as powerhouses of divergent evolution has never been more elegantly demonstrated than here in the islands of Darwin's blessed youth. The sea turtle's tale, back to the sea and back again to the land. In the giant tortoise's tale, I described ancestral tortoises floating inadvertently from South America, colonizing the Galapagos Islands by mistake, subsequently evolving local differences on each island and giant size on all of them. But why assume that the colonizer was a land tortoise? Wouldn't it be simpler to guess that marine turtles, already at home in the sea, hauled up on the island beaches as if to lay their eggs, enjoyed what they saw, stayed on dry land and evolved into tortoises? No. Nothing like that happened on the Galapagos Islands, which have only been in existence a few million years. There is good evidence that the most recent common ancestor of all today's tortoises, including those on the mainlands of America, Australia, Africa and Eurasia, as well as the giants of Galapagos, Aldabra, the Seychelles and other oceanic islands, was itself a land tortoise. In their recent ancestry, to misquote Stephen Hawking, it's tortoises all the way down. The various giant tortoises of the Galapagos Islands are certainly descended from South American land tortoises. If you go back far enough, everything lived in the sea, watery alma mater of all life. At various points in evolutionary history, enterprising individuals within many different animal groups moved out onto the land, sometimes even to the most parched deserts, taking their own private seawater with them in blood and cellular fluids. In addition to the reptiles, birds and mammals and insects which we see all around us, other groups that have succeeded out of water include scorpions, snails, crustaceans such as woodlice and land crabs, millipedes and centipedes, spiders and their kin, and various worms. And we mustn't forget the plants, without whose prior invasion of the land none of the other migrations could have happened. Moving from water to land involved a major redesign of every aspect of life, from breathing to reproduction. It was a great trek through biological space. Nevertheless, with what seems almost like perversity, a good number of thoroughgoing land animals later turned around, abandoned their hard-earned terrestrial retooling, and trooped back into the water again. Seals and sea lions, such as the breathtakingly tame Galapagos sea lion, have only gone part way back. They show us what the intermediates might have been like on the way to extreme cases such as whales and dugongs. Whales, including the small whales we call dolphins, and dugongs, with their close cousins the manatees, ceased to be land creatures altogether and reverted to the full marine habits of their remote ancestors. They don't even come ashore to breed. They do, however, still breathe air, having never developed anything equivalent to the gills of their earlier marine incarnation. Other animals that have returned from land to water are pond snails, water spiders, water beetles, Galapagos flightless cormorants, penguins — Galapagos has the only penguins in the northern hemisphere — marine iguanas, found nowhere but Galapagos, and turtles, abundant in the surrounding waters. Iguanas are adept at surviving accidental oceanic crossings on driftwood, well documented within the West Indies, and there can be no doubt that the marine iguanas of Galapagos trace back to just such a piece of living flotsam from South America. The oldest of the existing Galapagos Islands is no older than 3 million years. Since the marine iguanas evolved here and nowhere else, you might think this sets a maximum limit on the date of their return to the water. The story is more complicated, however. The Galapagos Islands were made one after the other as the Nazca tectonic plate moved at about 10 centimeters per year over a particular volcanic hotspot under the Pacific Ocean. As the plate moved east, from time to time the hotspot punched through, delivering another island along the production line. This is why the youngest islands are towards the west and the oldest to the east. But at the same time as the Nazca plate continues to move east, it is also being subducted under the South American plate. The easternmost islands sink under the sea at a rate of about 1 centimeter per year. It is now known that although the oldest existing island is only 3 million years old, there has been an eastward moving and sinking archipelago in this area for at least 17 million years. Islands now submerged could have provided the initial haven for iguanas to colonize and evolve at any time during those 17 million years. There would have been plenty of time for them to island hop before their original ancestral island sank beneath the waves. Turtles went back to the sea much longer ago. They are, in one respect, less fully given back to the water than whales or dugongs, for turtles still lay their eggs on beaches. Like all vertebrate returnees to the water, they breathe air, but in this department they go one better than whales. Some turtles extract additional oxygen from the water through a pair of chambers at the rear end, richly supplied with blood vessels. One Australian river turtle, indeed, gets the majority of its oxygen by breathing, as an Australian would not hesitate to say, through its arse. There is evidence that all modern turtles are descended from a terrestrial ancestor who lived before most of the dinosaurs. There are two key fossils called Paleocursis quenstidae and Progonochelys talampaiensis, dating from early dinosaur times, which appear to be close to the ancestry of all modern turtles and tortoises. You might wonder how we tell whether fossil animals, especially if only fragments are found, lived on land or in water. Sometimes it's pretty obvious. Ichthyosaurs were reptilian contemporaries of the dinosaurs, with fins and streamlined bodies. The fossils look like dolphins, and they surely lived like dolphins, in the water. With turtles, it is a little less obvious. One neat way to tell is by measuring the bones of their forelimbs. Walter Joyce and Jacques Gautier at Yale University took 3 key measurements in the arm and hand bones of 71 species of living turtles and tortoises. They used a kind of triangular graph paper to plot the 3 measurements against one another. Lo and behold, all the land tortoise species cluster in the lower part of the triangular graph. All the water turtles formed a tight cluster of points in the upper part of the triangle. There was no overlap, except when they added some species that spend time in both water and land. Sure enough, these amphibious species show up on the triangular graph halfway between the wet cluster and the dry cluster. Well then, to the obvious next step. Where do the fossils fall? The hands of P. quenstidae and P. talampaiensis leave us in no doubt. Their points on the graph are right in the thick of the dry cluster. Both these fossils were dry land tortoises. They come from the era before our turtles returned to the water. You might think, therefore, that modern land tortoises have probably stayed on land ever since those early terrestrial times, as most mammals did after a few of them went back to sea. But apparently not. If you draw out the family tree of all modern turtles and tortoises, nearly all the branches are aquatic. Today's land tortoises constitute a single branch deeply nested among branches consisting of aquatic turtles. This suggests that modern land tortoises have not stayed on land continuously since the time of P. quenstidae and P. talampaiensis. Rather, their ancestors were among those who went back to the water, and they then re-emerged back onto the land in relatively more recent times. Tortoises therefore represent a remarkable double return. In common with all mammals, reptiles and birds, their remote ancestors were marine fish, and before that various more or less worm-like creatures stretching back still in the sea to the primeval bacteria. Later ancestors lived on land and stayed there for a very large number of generations. Later ancestors still evolved back into the water and became sea turtles. And finally, they returned yet again to the land as tortoises, some of which, though not the Galapagos giants, now live in the driest of deserts. I have described DNA as the genetic book of the dead. Because of the way natural selection works, there is a sense in which the DNA of an animal is a textual description of the worlds in which its ancestors were naturally selected. For a fish, the genetic book of the dead describes ancestral seas. For us and most mammals, the early chapters of the book are all set in the sea, and the later ones all out on land. For whales, dugongs, marine iguanas, penguins, seals, sea lions, turtles, and, remarkably, tortoises, there is a third section of the book which recounts their epic return to the proving grounds of their remote past, the sea. But for the tortoises, perhaps uniquely, there is yet a fourth section of the book, devoted to a final, or is it final, re-emergence, yet again to the land. Can there be another animal for whom the genetic book of the dead is such a palimpsest of evolutionary U-turns?